Hi, my name's Jim. My amateur radio call is November 8 X-Ray Yankee November and 8XYN. And currently I'm temporary AG, which means I just passed my general after nearly 20 years of being a technician, but that's a whole different story. What I want to do is I want to do a real quick review of this new device I bought a couple of weeks ago. It's the MFJ-933B magnetic loop antenna tuner. I have to try to make this relatively fast since YouTube has a 10-minute limit. The basic function of the device is it takes a loop of wire or other conductive material shorter than 1/4 wavelength and converts it into a high-efficiency transmitting loop antenna. Now, why might one want to do this? There are several reasons. The main one being limited space situations. I have recently found myself in a very limited situation. I really can't have any outdoor antenna to speak of unless I can pass it off as an HD TV antenna, which is possible at VHF and UHF, but pretty nearly impossible at HF frequencies. After checking into several possibilities for small indoor antennas, I came across a magnetic loop antenna. The magnetic loop antenna, as I said, is simply a loop of conductive material less than 1/4 wavelength in total length with a capacitor across it. This capacitor brings the loop into resonance at whatever frequency one might be interested in. Well, MFJ builds 4 of these models. The one I'm using is the 933B, which the difference between it and the other 2 high-power models is this one has no metering on it, which I didn't think would be necessary at the time. What it is capable of doing is it's capable of bringing, for instance, this loop of wire that's currently on the antenna is actually 3/8 inch copper tubing. I picked copper tubing for a couple of reasons. Number one, the thicker the conductor is, the more efficient the overall antenna design is. Number two, the copper tubing at 3/8 inch is fairly easy to work with, easy to bend, easy to drill, and produces a fairly efficient loop. MFJ recommends using number 10 wire of various lengths for their loops. Number 10 wire is actually 0.102 inches in diameter. It's pretty small. The smaller the diameter of the conductor, the lower the efficiency of the antenna is, but the greater the portability. Now, MFJ manufactures their own air variable capacitors in this design. The reason they use air variables is there are no rotating contact points on an air variable capacitor. Therefore, it reduces the overall losses of the unit. In an antenna of this type, for instance, according to the calculations that I've run, you could quite easily achieve 4,000 or 5,000 volts at up to 70 or 80 amps of current just running 100 watts. Even very small contact losses can reduce efficiency enormously. So MFJ engineered their own variable capacitor. They don't import it. They don't buy it from a third party. They actually produce it themselves. While the build quality is not absolutely the best in the world, it's certainly not the worst either, and it does do the job. It has a tuning range of about 20 to 80 picofarads, 20 to 85 picofarads, which, in my opinion, is not ideal. I would prefer something more on the order of 5 to 50 picofarads, simply because if I'm operating with something that'll tune down to 5 picofarads, I can actually use a radiator that very closely approaches 1/4 wavelength in length. The closer it approaches that wavelength or that point of wavelength, the higher the efficiency of the antenna goes. For instance, this loop on this antenna right now was cut as best as I could cut it. For 10 meters, it was cut for 28.5 megahertz. The overall loop length is about 5.5 feet, which is far short of a 1/4 wave. The efficiency is right around 70% with this conductor size. With the 10-gauge wire, the efficiency level, according to the software I was using, was more around 30%. This is unacceptable to me. But It does work. Now, I'll point out as quick as I can. Like I said, I have a 10-minute limitation. This is killing me. The main knob, the tuning knob. This is what actually brings the air variable capacitor into tune. It actually causes the loop to appear to be physically longer than it is. This can bring, this is the control you use to bring the physical loop into resonance. The other capacitor next to it is an air variable, but not a butterfly capacitor. It's used for fine-tuning the actual coaxial connection to the resonance circuit of the antenna. Works very well, does its job quite effectively. Rear of the device. The rear of the device is pretty straightforward and simple. There are two wing nuts which connect the radiator or the conductor of your choice to the butterfly capacitor. They are physically part of the butterfly capacitor. They are not separate. They're not held on by wire. There's no wire attached to them. They are really physically part of that capacitor. Once again, that's to improve efficiency. The fewer contact points, the greater the efficiency. Coaxial connector, standard coax connector, right below that. Does the device work? Yes, it works. In a limited space environment, I would say it's probably one of your better choices. It has a very limited bandwidth. Once you've tuned the unit, you can't wander off by more than 50 to 100 kilohertz before you have to retune the unit. The SWR will simply go off scale at that point. The upside of this, well, the antenna acts as a very good pre-selector. If I had a signal that was 60 dB over S9, 100 kilohertz away from my operating frequency, I wouldn't detect it. It would simply be rejected by the antenna. The antenna does have a pattern. It's bidirectional. It radiates off either side of the radiator. Right now it's in the vertical position, so it'll radiate off this side, and it'll radiate off this side. Now, if you lay it horizontal, well, it has the central area, the donut area in the center is a null. Now, if you lay the thing horizontally, the null will be both above and below the antenna with a radiation pattern around the antenna. This is going to give you a very low angle of radiation and probably really good DX results. That would be my guess. Now, how well does the antenna work? Works pretty well. I'm going to show you something real quick. Just give me a second. I'm going to pause this, and I'm going to have to edit it back in. I still have to. What I've done is I've placed a fluorescent bulb on the unit. It's not in contact with anything at all. This unit will develop literally. It's rated at 150 watts. At 150 watts of power, this unit will literally generate 4,000 to 5,000 volts of RF across it, and it can generate upwards of 70 or 80 amps of current. It is very dangerous. Keep people away from it while in operation. Right now, I've got it hooked to a CB since that is my lowest power producing radio at this point. So, let's watch what happens when we key up this CB with that light bulb sitting there. Hello, 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 hello radio. That's 4 watts of RF output. That's 4 watts, and it is really lighting up that light bulb. The near field is incredibly strong on this unit. As I said, it's not a toy. It's not anything to be toyed with. Caution should be used at all times while operating this. November 8, X-Ray Yankee November. Jim saying, good evening.